Welcome to this exciting video where we will be exploring the incredible power of Looker as a data visualization tool. In today's data-driven world, being able to understand and communicate insights effectively is paramount, and Looker is here to revolutionize the way you visualize and explore your data. Data visualization is not just about creating pretty charts and graphs, it's about unlocking the stories hidden within your data and empowering decision-makers with actionable insights. And that's where Looker shines. With its intuitive interface and robust capabilities, Looker enables you to transform raw data into compelling visualizations that unveil patterns, trends, and opportunities. Join us on this journey as we unlock the full potential of Looker as a data visualization tool. Make sure to like this video, subscribe to our channel, and let's dive right into the exciting world of Looker's data visualization capabilities.
Looker operates in two modes: production mode and development mode. In production mode, all users experience the same version of Looker with read-only project files, explores, and content. However, in development mode, developers can make changes to Looker without affecting others. This mode uses a separate version of project files that only the developer can see and edit. The ID and Explore menus offer different features and options in production mode versus development mode, depending on your permissions and local code differences. Git is a version control system that Looker integrates with for version control of LookML projects. LookML is always written in one branch or another. The main production code acts as the trunk of a tree, while each developer branches off the trunk to create new features such as fields and explores. Whenever you edit a LookML file, a blue dot appears next to its name in the file browser. Developers should pull in any changes from other developers before making their own changes to LookML, saving and committing as needed. When you validate your LookML code, the LookML validator checks your syntax for errors and warnings, which you should resolve before proceeding to the next step of the Git workflow. After validating your code, the next step in the Git workflow is to commit changes and push. It is best practice to add a brief comment explaining the commit's purpose and commit whenever you've completed a reasonable unit of work. After committing, you can merge and deploy to prod, making the changes visible to business users immediately. If there is a merge conflict, you must choose which version to keep and commit again before proceeding to merge and deploy. Organizations may require code review through pull requests before deploying changes. Looker can support this workflow through its project settings, where Looker admins can configure the project to enforce pull requests recommended or pull requests required. With this setup, a colleague must review and merge the pull request in the Git provider itself upon approval, instead of the developer merging and deploying the changes. Shared branches, also known as feature branches, allow developers to collaborate on the same code version. Shared branches can be useful if developers need to work together on a new feature or bug fix. Developers commonly create a new shared branch for each ticket or Jira issue, then delete the branch once the unit of work is completed. In summary, Looker operates in two modes: production mode and development mode, and Git is used for version control of LookML projects. Developers can edit LookML files in development mode and push changes to production mode, where business users experience Looker's latest version. Pull requests and shared branches can facilitate team collaboration on Looker projects.
Today we're diving into the advanced world of derived tables. As you know, derived tables are essential tools in Looker that can help you expand the sophistication of your analyses and even enhance query performance. At their core, derived tables enable you to create new tables that don't already exist in your database, either as temporary or persistent tables. You define a derived table by writing or providing a SQL query, and the results of that query become the derived table. And, just like any other table, you can reference it in a LookML view. Derived tables have two phases of existence: ephemeral and persistent. Ephemeral tables compile at runtime, when a business user needs it in an Explore query. On the other hand, persistent tables are written back to the database and stored there, so they're readily available when a business user needs it in an Explore query. There are two ways to write derived tables: in SQL or in LookML. SQL-derived tables tend to be easier for people who already have SQL backgrounds but aren't fully comfortable with LookML yet. To create a SQL-derived table, you can use SQL Runner, which allows you to write out the query you want and see the results before adding it to your project. Here's a use case for when a derived table would be needed. Let's say we want to know the average number of items purchased per order by age group. We can count the number of items by doing a count, distinct order item id, or count, asterisk. But to get the average, we need an orders sort of summary or fact table where we are only granular to the order level, and item count is not an aggregate function but a dimension of the order. Once we have this derived table, we can see at the user level what the average number of items purchased per order is. Once you've confirmed that your SQL query is valid and does what you want, you can add it to your project and customize it in LookML. Looker auto-generates a dimension for each column SELECTED in the SQL query, but you should remove the limit clause, add primary keys, and define the measures and dimensions you need. So there you have it, folks. Derived tables can take your Looker game to the next level, and now you're equipped with the tools to master them. Keep exploring and expanding your knowledge, and as always, happy coding.
Native derived tables, NDTs, in Looker are expressed in LookML instead of SQL, providing a more reusable and maintainable approach to modeling data. By inheriting existing dimensions, measures, explores, and join logic, NDT minimize the need for hard-coded database references, making the model more efficient in the long run. Creating an NDT is easy through an Explore. Select the dimensions and measures for your derived table, and the Explore will generate a valid, performant SQL query. Unlike SQL-derived tables, validation is not required to proceed. To create an NDT, click on the gear icon in the top right corner of the Explore, select Get LookML, and copy the LookML code to your clipboard. Then create a blank view file, paste the LookML into it, and rename the view. Looker suggests including the model file to enable real-time field suggestions and error checking. However, it is not a good practice as model files often include other files that can create circular dependencies and confuse Looker. Instead, we recommend isolating the source Explore to a standalone LookML file and including it in the model file. The NDT parameters include the Explore source parameter that points to the Explore in your model that serves as the foundation for the derived table, and the column parameter that specifies the output column for the derived table. Filters, derived columns, bind filters. An expression custom filter can also be used to apply filters, introduce logic, and define nuanced logic with your own choice of and / or conjunctions and order of operations. In conclusion, NDT are a more maintainable and efficient approach to modeling data in Looker, making the model more readable and understandable. By using NDT, you can streamline your Looker modeling process and reduce the number of hard-coded references to your database. Welcome to this discussion on Looker's parameters, a powerful feature that enables users to input values and incorporate them into generated SQL using Liquid, an external templating language. Parameters play a crucial role in LookML, allowing us to create dynamic and customizable filters. Each parameter is assigned a type, such as string, number, or date, along with a set of allowed values. These values seamlessly integrate into the SQL query, providing flexibility and interactivity. The label attribute enhances user experience by presenting human-readable filter options. In LookML, we utilize Liquid to reference parameter objects, dynamically incorporating the chosen parameter value into the SQL query. Additionally, the label from parameter attribute allows us to modify the appearance of dimension columns based on the selected parameter label. On the front end, users can conveniently select values from a drop-down list associated with the parameter. Any changes made by the user are immediately reflected in the generated SQL, enabling on-the-fly adjustments to the select statement for a specific dimension. Parameters prove especially valuable in maintaining clarity within explorers that involve similar fields. For instance, we can consolidate multiple levels of granularity into a single dimension, allowing users to modify the granularity based on their desired filter inputs. Creating a parameter object involves assigning a name and defining its type. We can specify allowed values and even set a default value if needed. Subsequently, we reference the parameter in LookML code using Liquid and its corresponding name. When incorporating user input into the generated SQL, we can utilize placeholders or conditional statements to select the parameter value and determine which dimension to use. In summary, Looker's parameters empower users to input values dynamically, integrating them into generated SQL using Liquid. With their versatile functionality and customizable options, parameters enhance the flexibility and interactivity of data exploration. By utilizing parameters, users can easily create dimensions with varying levels of granularity. Parameters offer a robust toolset for optimizing data analysis and visualization in Looker, facilitating a more intuitive and tailored data exploration experience. Looker, a revolutionary cloud application, has revolutionized the way we interact with data. This essay explores Looker's capabilities, user interface, and its potential for data analysis and transformation. Users can unlock the power of data through Looker, making informed decisions and embarking on a path of growth and discovery. Looker is accessed through an internet browser, providing a user-friendly interface for users of all technical proficiencies. With tailored features for viewers, explorers, developers, and administrators, Looker caters to each user's specific needs. The top navigation bar offers Browse, Explore, Develop, and Admin options, allowing users to easily navigate through shared folders, personal folders, and boards. Recent views, favorites, and popular content can be accessed effortlessly. For explorers, Looker provides curated portals known as Explorers, where users can ask questions of their data. Developed using LookML, these explorers offer valuable insights for informed decision-making. Developers utilize the Develop tab to customize explorers, fields, and logic to meet their organization's specific needs. Administrators manage users, permissions, and settings through the Admin tab. Looker's search functionality enables users to locate specific content quickly, while robust documentation and user guides provide comprehensive resources. Regular updates and new features ensure Looker remains at the forefront of data analysis and visualization. Dashboards in Looker offer comprehensive business intelligence tools with various visualizations, empowering users to track progress, identify trends, and make data-driven decisions. The Explore interface allows users to build reports, analyze data, and extract insights. By selecting dimensions and measures, marketers can segment their audience, apply filters, and gain a comprehensive understanding of customer behavior. Looker empowers users to leverage data, make informed decisions, and drive meaningful change. It serves as a catalyst for growth, uncovering hidden patterns, identifying opportunities, and addressing challenges. In conclusion, Looker is a transformative platform that empowers users to harness the power of data. Through Looker, users can unlock insights, make informed decisions, and drive meaningful change in their organizations.
Table calculations in Looker enable users to define on-the-fly metrics and perform custom calculations within an Explore. They offer flexibility but come with risks and limitations. To create and modify table calculations, users access the Custom Fields view in an Explore with the required permissions. However, excessive use of table calculations can undermine data governance, which relies on Explorers as single sources of truth. Table calculations are not saved automatically and must be recreated when accessing an Explore. Thus, it's recommended to use them for prototyping or one-off questions and involve LookML developers for recurring logic. Table calculations can also address limitations in visualizations or features. To create a table calculation, users bring in dimensions or measures, access the Custom Fields view, and define the name and formula. Looker supports Excel-like functions, including absolute value, time intervals, concatenation, and if conditions. Results can be formatted and table calculations appear in the data table and visualizations. Users can hide table calculations or foundational dimensions/measures in visualizations. Table calculations fall into 4 types: string, mathematical, logical, and date and time. String functions manipulate text for improved readability. Mathematical functions perform arithmetic, averages, sums, and more. Logical functions evaluate conditions and execute different logic paths, such as determining profitability. Date and time functions extract time periods and calculate date differences and additions. In conclusion, Looker's table calculations enable the derivation of on-the-fly metrics and custom calculations. They should be used judiciously to maintain data governance. Engaging LookML developers for recurring logic is advised. By adhering to best practices, users can fully utilize Looker's capabilities while upholding data integrity and governance. Caching in Looker is a valuable feature that reduces database load and enhances performance. It is implemented through data groups, lookML objects used to define caching policies. By saving and reusing prior query results, caching minimizes the need to repeatedly run queries on the database, resulting in improved efficiency. When a query is executed in Looker, both the SQL and its results are stored in an encrypted file on the Looker instance. When subsequent queries are made, Looker checks if the exact same query has been executed before. If it has, Looker evaluates the caching policy to determine if the cached results are still valid. If they are, Looker quickly retrieves the cached results, typically within half a second. However, if the results are no longer valid, Looker sends the query to the database to obtain fresh results, which are then cached for future use. Data groups can be applied at the model level, overriding the caching rules for all explorers within that model. Additionally, data groups can be applied to individual explorers, ensuring consistent caching logic for looks and dashboards. Schedules for looks and dashboards can also be run on data groups, automatically refreshing the cache when the caching policy expires. Data groups are defined using two parameters, SQL trigger and max cache age. The SQL trigger parameter involves a select statement that returns a single value and is regularly executed to check for changes in the underlying data. The frequency of the SQL trigger's execution is determined by the Looker admin and can be customized based on the data source's update frequency. For example, it can be set to execute every 5 minutes or once per day at midnight. By detecting changes through the SQL trigger, Looker invalidates the cache, ensuring that queries retrieve up-to-date data. The max cache age parameter specifies the duration for which cached results are considered valid, regardless of changes in the data. Some users opt for a fixed max cache age, such as 1 hour, while others combine it with the SQL trigger to refresh the cache after a specific period, such as 6 hours, even if no changes are detected. This approach ensures that the cache remains fresh and aligned with the latest data. Configuring a data group involves a two-step process. First, the data group is defined, specifying the SQL trigger and max cache age parameters. However, the data group itself does not take effect until it is applied using the persist with parameter. By persisting with a data group in the model file or within the definition of an explorer, the defined caching rules are enforced, enabling efficient cache management. In conclusion, caching in Looker, facilitated by data groups, significantly improves performance by reusing previously executed query results. The combination of SQL trigger and max cache age parameters ensures efficient cache management and enables the retrieval of up-to-date data for analytical purposes.
Let's talk about persistent derived tables, PDTs, in Looker. PDTs are stored in the connected database, providing ready-to-use data for business users and reducing query run times. However, they come with considerations of storage space and rigidity. To persist a derived table, we have parameters like datagroup trigger and SQL trigger value. Datagroup trigger utilizes a configured datagroup, serving as a caching policy and trigger for PDT rebuilds. It's the best practice for persisting derived tables. SQL trigger value performs a similar function, continuously pinging the database and rebuilding the PDT when a change is detected. While persist_for instructs the PDT to remain available for a set duration, it's not recommended to rely on it alone due to the lack of rebuild logic. However, when combined with SQL trigger value, persist_for can act as a failsafe. Indexing is crucial for optimizing PDT storage, improving query processing efficiency. Datagroup trigger as the recommended method for persisting derived tables, aligning query caching policies and database ETL processes with PDTs. Looker checks if the SQL trigger result from the datagroup is changed, triggering PDT rebuilds and invalidating cached results. SQL trigger value can be used to define different persistence logic, while persist_for is best used in combination with SQL trigger value. PDTs run a SQL create statement and become physical tables in the underlying database. Business users can access separate versions of PDTs in production mode. In conclusion, PDTs offer a powerful way to store and reuse data in Looker. By persisting derived tables, we improve performance and provide readily available data for informed decision-making. Remember to leverage parameters like datagroup trigger and SQL trigger value and optimize storage through indexing. Looker empowers organizations with consistent and reliable data analytics. Together,
Let's unlock the full potential of PDTs and revolutionize the way we understand information. Stay curious, innovative, and let Looker guide us to new frontiers of knowledge and discovery.
In this comprehensive exploration of Looker's powerful features, we've delved into various aspects that empower users to optimize their data analysis and visualization workflows. From understanding the different modes of Looker, utilizing version control with Git for Look ML projects, harnessing the capabilities of derived tables and table calculations, to leveraging parameters and caching, we've covered a wide range of topics. Looker's production mode and development mode provide users with distinct environments for accessing and editing project files, while Git integration ensures efficient version control and collaboration. Derived tables enable users to create new tables on the fly, enhancing analysis capabilities and performance. Table calculations allow for custom metrics and calculations within explorers, enabling tailored insights. Parameters offer dynamic and interactive filtering options, while caching reduces database load and enhances query performance. By understanding these features and best practices, users can unlock the full potential of Looker, empowering themselves to efficiently explore and analyze data, derive valuable insights, and make data-driven decisions. Looker's robust functionality, combined with thoughtful implementation and adherence to data governance principles, ensures a seamless and impactful data exploration experience. Remember to leverage the power of Looker to streamline workflows, collaborate effectively, and uncover the stories hidden within your data. Whether you're a data analyst, business intelligence professional, or decision maker, Looker equips you with the tools to drive informed and strategic actions based on accurate and actionable insights. So dive in, explore, and embrace the power of Looker as you embark on your data-driven journey. Stay curious, innovative, and let Looker guide you towards new frontiers of knowledge and discovery.